Hi everyone, welcome to Go Classes. In this session, we are going to start planar graph. We are going to study what is the concept of planar graph, when can I say a graph is planar, and when can I say a graph is not planar graph. Okay, so this is the concept that we need to study. So let's start. First, let's see what is edge crossing in a 2D drawing. What is a 2D plane? What is a 2D plane? 2D plane means this plane, our seat. For example, this is your 2D plane. Like, for example, I can say XY plane. Okay. So this is your 2D plane. Now, what is the concept of edge crossing? When can I say two edges are crossing in a 2D drawing? In a 2D drawing, when can I say two edges are crossing each other? Okay. See, very simple. If you have two edges, let's assume you have edge E1, edge E2. You have edge E1, edge E2. Now, if you draw these two edges on the 2D plane, if you draw these edges like this, that they are crossing. For example, let's assume this is E1, this is the edge E1, and let's assume this is the edge E2. Okay, you are drawing these edges in such a way that they are crossing each other in the 2D plane. Okay, in the 2D plane, they are crossing each other. You can see. Okay, you can see in the 2D plane. Look at the 2D plane. In this 2D plane, you can see this edge E1, E2, they are crossing each other. This is the intersection. So you can see they are crossing each other. This type of drawing is called drawing with edge crossing. Okay, so remember this drawing. If I draw like this, then this is called drawing with edge crossing. Okay, with edge crossing. Is this clear? So this is the drawing with edge crossing. If you draw like this, you are drawing, you are the painter. Okay, so let's assume you are the painter. Now, you are drawing, and if you draw like this, two edges you are drawing like this, that they are intersecting. You can see they are crossing each other in the 2D plane, in the 2D drawing. Then this type of drawing will be called drawing with edge crossing. Is this clear? Please tell me. Okay, so this type of drawing, what we call it? We call it drawing with edge crossing. And you can see these two edges, if you draw like this, for example, let's assume this edge you draw like this, and this edge E2 you draw like this, for example. Okay, now you can see they are not crossing each other. Okay, they are not crossing each other. But you can see if you draw like this, edge E1, E2, if you draw like this, then they are crossing each other in the 2D plane, in the 2D drawing. Okay, so very simple point. So this type of drawing is called drawing with edge crossing. Now let's see what the concept of planar graph. What is the definition of planar graph? So let's see. The definition of planar graph is very simple. A graph is called planar graph if there is some way to draw it in the 2D plane without any edge crossing. Read this definition. This is very important definition. You can see a graph is planar graph if there is some way, remember, if there is some way to draw it in the 2D plane without edge crossing. Okay, can you draw this graph in the 2D plane without edge crossing? If you can do that, then this type of graph will be called planar graph. Planar graph means you can draw this graph. There is some way. Remember, this is very important. This is very important. This is very important that there is some way. Okay, so remember, this is very important. Okay, so what we are saying that there is some way to draw this graph in the 2D plane without any edge crossing. Without any edge crossing. So this type of graph will be called planar graph. Okay, so let's start with this question. Let's see this question. Is this a planar graph? Tell me. Is this a planar graph? On your screen, you can see I have given you a graph. Now you tell me, is this a planar graph? Is this graph planar? Can I say this graph G you have, is this graph planar? This graph G, is this graph planar? Okay, these are the vertices. Let's assume vertex A, B, C, D. Is this graph planar? The answer is yes. This graph is planar, because read the definition of planar graph. A graph is planar. A graph is planar if there is some way to draw it in the 2D plane without edge crossing. Can you draw this graph without edge crossing in the 2D plane? Can you draw? See, this graph is planar. Let me tell you. Is this graph planar? The answer is yes. Why? What is the reason? What is the reason? Because there is some way. As I told you, this is very important. Again, I am telling you, this is important point. Okay, this is important. See, a graph is planar. When can I say a graph is planar graph? A graph is planar graph if there is some way, to draw in the 2D plane without any edge crossing. Can you draw this graph without edge crossing? Tell me, can you draw this graph? This graph can you draw without edge crossing? Tell me. Yes, I can draw without edge crossing. For example, what I can do? I can do like this, A, B, C, D. Okay, I can do like this, C. Okay, what I can do? I can draw it without edge crossing. What I can do? Now, there is edge crossing here, right? See, very simple point. We have edge crossing here. Here you can notice these edges are crossing. These edges are crossing. So what I can do? This edge, this AD edge, I can put like this. This edge I can put like this. Yes or no? Now you can notice there is no edge crossing. So remember this G, this is also G. Both are G. Yes or no? Both are same graph. Both are same. Both are same. Both are same. Okay, so remember this G, this graph you can draw. There is some way to draw without edge crossing. So remember this graph is planar graph. So this graph is a planar graph. Is this clear? This graph is planar graph. Of course, this graph, this and this, they are same graph. Okay, so of course, this and this, they are same graph. So this is also planar graph. So both are planar graph, remember. Is this clear? Both are same graph. Both are same graph. So both are planar graph. Is this concept clear? Please tell me. So read the definition very carefully. I'm telling you, read the definition very carefully. See, the definition of planar graph. Is this clear? A graph is planar if there is some way to draw in the 2D plane without edge crossing. So remember, this point is very important. Okay, a graph is planar graph if there is some way. When can I say a graph is planar? If there is some way to draw in the 2D plane, without edge crossing. Without edge crossing. Okay, is this clear? So remember, if I give you a graph and then I ask you, is this planar graph or not? Then what you will do? You will try to draw this graph in the 2D plane without edge crossing. Okay, this is what you are going to do. Basically, you are going to find out, is there a way? Is there some way to draw this graph in the 2D plane without edge crossing? Okay, so this some way, this is important point. Again, I'm telling you, students make mistake here. Okay, so remember, there is some way to draw this graph in the 2D plane without any edge crossing. Let's see this example. Is this graph planar graph? Tell me. On your screen, this graph is given to you. Is this graph planar graph? First of all, you tell me, right now, is there any edge crossing in this drawing? First, you tell me, in this drawing, is there any edge crossing? First, you tell me, in this drawing, this is the drawing, I can say, in this drawing, is there any edge crossing? In this drawing, is there any edge crossing? Is there any edge crossing? First, you tell me this point. In this drawing, in this particular drawing, I'm asking in this particular drawing, remember, in this particular drawing, is there any edge crossing? The answer is yes. The answer is yes. For example, you can see these edges are crossing. Look at these edges. Yes or no? Look at this edge, look at this edge, look at this edge. They are crossing. Okay, so there is edge crossing. For example, you can look at this edge and you can look at this edge. Okay, again, they are edge crossing. So in this particular drawing, is there edge crossing? Yes. Okay, there is edge crossing. Now you tell me, is this graph planar? Is this graph planar? So can I say there is edge crossing in this drawing? In this drawing, there is edge crossing. So can I say this graph is not planar? In this drawing, look at this drawing. In this drawing, there is edge crossing. So can I say this is not planar? No. Remember, a graph is planar if there is some way to draw in the 2D plane without edge crossing. Okay. So basically, remember, a graph is planar if there is some way, to draw this graph in the 2D plane without edge crossing. So can you draw this graph in the 2D plane without edge crossing? Can you do that? Yes, very simple. See, very simple point. Let's mark these vertices. This is A, this is B, this is C, D, and then you have E, F, G, H. Okay, so these are the vertices. Now, can you draw this graph in the 2D plane? This is your cube, right? Yes or no? In the school life, you have seen this. This is your cube. So can you draw it without edge crossing? Very simple. What you can do? This front face you can put here. This front face you can put here. Okay, E, F, G, H. Okay, this front face you can put here. And this back face you can put here. A, B, C, D. A, B, C, D. Okay, and then you can make the connections. These connections you can make. Okay, these connections you can make. Is this clear? Please tell me. Let me know. Can you notice? They are same graph. These two graphs are same. Okay, this is G2. This is G2. This is also G2. Both are G2. Both are same graph. Both are same graph. But you can notice this drawing has edge crossing. This drawing does not have any edge crossing. Is this clear? Please tell me. So is this graph planar graph? The answer is yes. The answer is yes. Okay, this graph is planar graph. Remember, this graph G2 is planar graph. Okay, this graph. Remember this graph. Is this graph planar graph? The answer is yes. Because you can draw this graph without edge crossing. Okay, you can see this same graph I can draw without edge crossing. So I can say this is the drawing without edge crossing. Is this clear? Please tell me. Okay, so this is the drawing without edge crossing. So I can say, is this planar graph? The answer is a yes. Yes, this is a planar graph. And I can say that this is the drawing without edge crossing. Okay, this particular drawing. Look at this. I can say this is the drawing with edge crossing. Please notice. This is the drawing with edge crossing. This is the drawing with edge crossing. And this is the drawing without edge crossing. And this is the drawing without edge crossing. The same graph, but you can draw without edge crossing. Without edge crossing. So I can say, yes, they are planar graph. This is also planar. This is also planar because they are same graph. Okay, so this is a planar graph. Very simple point. I hope you understood. So you can see this graph, you can draw like this. Okay, so here you can see there is edge crossing. If you draw like this, there is edge crossing. Yes or no? If you draw like this on the 2D plane, if you draw like this, there is edge crossing. But this same graph you can draw like this. This same graph I can draw like this. I can say redraw. Okay, I can say that you can draw like this. Okay, without edge crossing. So remember, this is a planar graph. This is a planar graph. This is a planar graph, and this is also a planar graph. Both are planar graph. Okay, very simple point. Is this clear? Let me know. Now let's move on. So let's see this question. This is UGC NET computer science question. So tell me what will be the answer for this question. Two graphs A, B are given to you. Which of the following statement is true? The question is asking which of them is planar. So we have already seen that this option A, this is a planar graph. Option B, this is also a planar graph. Okay, yes or no? Both are planar, because what you can do, you can redraw without edge crossing. Okay, this graph A, you can draw without edge crossing. This graph B, you can draw without edge crossing. We have already seen. Okay, so very simple question. The answer will be option A. Now let's see this question. Is this graph planar? K2, n. For all n, whatever n you take, this is your complete bipartite graph. This is your complete bipartite graph. This is your complete bipartite graph. Okay. This is your complete bipartite graph K2, n. Now tell me, is this a planar graph? Is this a planar graph? Take copy pen and check. This K2n, is this a planar graph? For example, what will be K23? Or maybe I can say what will be K24? What will be K24? K24 means one part has two vertices. Okay, yes or no? One part has two vertices. These are the two vertices. One part has two vertices. Another part has four vertices. C, D, E, F. Okay, yes or no? K2 and K24. This is I can say this is your complete bipartite graph. Okay, so this is your complete. I'm drawing like this. So this is a complete bipartite graph. Now you tell me, is this planar graph? This graph on your screen, is this planar graph? Simple question I'm asking, is it planar? Is this graph planar? Is this graph planar? First you tell me, in this drawing, do we have edge crossing? In this particular drawing, do we have edge crossing? Yes, there is edge crossing in this particular drawing. But I'm asking, is this graph planar? Means, can you draw without edge crossing? Okay, so remember this point. In this particular drawing, there is edge crossing. In this particular drawing. Okay, please understand. In this particular drawing, there is edge crossing. There is edge crossing. In this particular drawing, there is edge crossing. But is there any drawing without edge crossing? In this particular drawing, there is edge crossing, but my question is, but is there any drawing without edge crossing? Is there any drawing? Is there any drawing without edge crossing? Is there any drawing without edge crossing? That is the question. Yes or no? Is there any drawing? Do we have any drawing? Is there any drawing without edge crossing? This is the question. So tell me, can you draw this graph without edge crossing? Yes, very simple. See, this is your K24. You can draw it without edge crossing. What you can do, this same graph, you can draw like this. What you do, you remove this B from here. You put this B here. Okay, you remove this B from here. Basically, this is K24. Okay, one part has 2 vertices. Another part has 4 vertices. Now, the same graph you can draw like this. Yes or no? Please tell me, did you understand? Now there is no edge crossing. The same graph I can draw like this. Yes or no? This is same graph we have redrawn. Okay, we have redrawn the same graph. The same graph we have redrawn without edge crossing. The same graph you can draw without edge crossing. Is this clear? Please tell me. Okay, so remember, we have drawn the same graph without edge crossing. Is this clear? Is this clear? Please tell me. Let me know. So remember, is this graph planar? The answer is yes. Okay, so remember this K24, this is a planar graph. This graph is planar graph. Okay, so remember this graph is planar graph. Okay, is this clear? Please tell me. Let me know. Because you can draw this graph without edge crossing. Okay, you can see this is redrawn without edge crossing. You can see this is the drawing without edge crossing. Is this clear? Please tell me. This is the drawing of K2n. This is the drawing of K2, n without edge crossing. Without edge crossing. Okay, is this clear? So remember this K24, this is your planar graph. Similarly, this K2n, this is also planar graph. Is this clear? Let me know. So remember every K2n that is planar. Is this clear? So remember every K2n, every K2, n is planar graph. Okay, every K2n is planar graph. Yes or no? Very simple point. Whatever K2n you take, that is planar graph. Because what you will do, please tell me. What you will do like this. Okay, here you have these vertices, here you have n vertices, and another vertex you will put here. And what you can do? You can do like this. Okay, you can do like this. You can easily do like this. Okay, please tell me, is this point clear? Let me know. Okay, very simple. What about these graphs on your screen? Which of these graphs are planar graph? Let me tell you, this is your GATE Computer Science 2005 question. Which of these graphs are planar graph? 3 graphs are given to you. What about this G2? Is this planar? Yes, this graph G2, you can draw without edge cross. Which of these graphs is planar? I can say G2 is planar. This graph is planar because I can redraw this graph without edge crossing. I can redraw this graph. I can redraw without edge crossing. Okay. So is this clear? Please tell me. This G2, this is planar graph. The reason is because you can redraw. You can redraw this graph without edge crossing. So look at this graph. Look at this graph. This graph is planar graph. Why? Because you can redraw this graph without edge crossing. What you can do? This vertical edge that you have. Look at this vertical edge. This vertical edge you can put outside. You can put this vertical edge outside. Okay. Now let's see this G3. Is this planar graph? This G3. See, there is edge crossing here. In this G3, there is edge crossing. But can you redraw this graph without edge crossing? This graph G3, can you redraw without edge crossing? Please tell me. Can you redraw this graph without edge crossing? Yes. See, this edge I can put outside. Okay, look at this edge. I can put this edge outside. I can put like this. So this G3 also I can redraw without edge crossing. This G3, what I can do? This is the G3 that you have. This is your graph G3. Now what I can do? This edge, look at this edge. Look at this edge. This edge I can put outside. This edge I can put like this. Okay, so what I can do? I can put this edge like this. So again, you can notice there is no edge crossing. So this G3, this is also planar. This is also planar graph. Okay, so remember, this graph is also planar. This is also planar. What about the next? What about this one? G4. Is this planar graph? This graph G4, is it planar? Please tell me. Is this graph planar? Yes, this is also planar because you can redraw this graph without edge crossing. Can you try? Can you try this graph G4? This is also, you can draw this graph without edge crossing. See, these are the vertices A, B, C, D, E. These are the vertices. Now you can redraw this graph without edge crossing. What you can do? Very simple. A, B, C, D, E. Okay. So what you can do? This graph also you can redraw without edge crossing. So let me try. Let me try. This graph also you can draw without edge crossing. Okay. So how you will do this? Please tell me. See, very simple. Very simple. What I can do? This is, look at this edge. Okay. Look at this edge. I can put this edge like this. Okay. This edge I can put like this. And this edge I can put, see what I'm doing. This B edge I can put outside. This B edge I am putting outside. Okay. This BE. This edge I am putting outside. Similarly, this AE edge also I can put outside. This AE edge, this also I can put outside. Okay. Yes or no? Now what else is remaining? What else is remaining? So B, comma AE. Those are done. Next, ADBC. ADDC. Okay. AD and DC. Now tell me, is there any edge missing? Is there any edge missing? See, these are the outside edges, and then there are 1, 2, 3, 4 edges. Okay, so you can see outside edges, 4 edges. Yes, you can see there is no edge crossing now. Is this clear? Please tell me. So can you notice this graph? This is also a planar graph because we can redraw without edge crossing. So this is also a planar graph. Is this clear? Please tell me. So remember, this is also planar graph. This graph is also planar graph because you can redraw this graph without edge crossing. Okay, this is your GATE Computer Science 2005 question. Okay, all of them are planar graph. Yes or no? Is this clear? Please tell me. All of them, they are planar graph. Now you tell me one thing. You tell me one thing. Same graph, if you have, for example, let's take this graph K4. Let's assume you have this graph K4. Okay. Now tell me, can I redraw this graph in multiple ways such that there is no edge crossing? Tell me, is it possible that there are multiple ways to draw this graph without edge crossing? Simple question I am asking. If you have a planar graph, this is my question. For a planar graph, okay, you have a planar graph. For a planar graph G, are there multiple ways? Are there multiple ways possible to draw without edge crossing? Are there multiple ways possible to draw without edge crossing? Tell me. Are there multiple ways possible? Or I can say, are there multiple drawing possible without edge crossing? Are there multiple drawing possible? Multiple drawings possible. Possible without edge crossing. Tell me. Without edge crossing, are there multiple drawing possible? The answer is yes. The answer is yes. Okay. Yes, multiple drawings can be there. Remember, there can be multiple drawings possible without edge crossing. For example, you can take this K4. For this K4, you can create many drawings without edge crossing. Okay. For example, this K4 you can draw like this. Okay. This K4, what you can do? You can draw like this. This K4 you can draw like this. Next, what you can do? This K4 you can also draw like this. Notice A, B, C, okay, D. This K4 you can also draw like this. Correct? Yes or no? So you can see that there are multiple ways possible. There are multiple ways possible to draw without edge crossing. Is there any other way possible? Please tell me. Is there any other way possible? Let me know. Is there any other way possible? Yes, there is another way possible. For example, A, B, C. Okay, and I put D here. I put D here. There is another way possible. See, there is another way possible. Is this clear? Please tell me. Let me know, is this understood? So remember, for the same graph, if you have a planar graph G, are there multiple drawing possible without edge crossing? The answer is yes. Okay. So remember this point. There are multiple. It is possible. There can be more than one drawing. There can be multiple drawing without edge crossing. Okay. For a planar graph, there can be multiple drawing without edge crossing. For example, for this graph, remember this K4 is planar. We have already seen this graph is planar graph. Okay, and this graph you can draw without edge crossing like this, or you can draw like this, or you can draw like this without edge crossing. Okay, so very simple point. So this is the definition of planar graph. A graph is planar if there is some way to draw in the 2D plane without edge crossing. Okay, very simple. This is the definition of planar graph. Now let's move on. Now let's see this question. Tell me, is there any graph which cannot be drawn without edge crossing? See, you might be thinking, so far every graph that we have seen, that is a planar graph. Okay, you might be thinking, yes or no, that so far every graph that we have seen, we can draw without edge crossing. Okay, every graph that we have seen, that is a planar graph. We can draw every graph. So far every graph that we have seen, we can draw those graphs without edge crossing. Now I'm asking, is there any graph which you cannot draw without edge crossing? Means, is there any non-planar graph? Is there any graph which you cannot draw without edge crossing? Means whatever drawing you make, definitely edge crossing will be there. Okay, whatever drawing you make, there will definitely be edge crossing. Means, is there any graph which is non-planar? The answer is yes. Let me know. Let me tell you, the answer is yes. For example, very popular graphs are there. Okay, remember the answer is yes. And the example, let me tell you the example. The example is K5. This is your complete graph on 5 vertices. Also K33, complete bipartite graph. So remember these graphs, these are very popular examples of non-planar graph. These two, K5, K33. These are very popular examples of non-planar graph. Means, look at this graph. This is your K33. This is your complete bipartite graph, K33. This graph cannot be drawn without edge crossing. We will prove it, don't worry. We will prove it. Okay, don't worry. We will prove it. So this is what I'm saying. Is there any non-planar graph? The answer is yes. For example, K5 and K33. Complete graph on 5 vertices. Also complete bipartite graph K33. These are non-planar graph. Let me tell you. Okay. Don't worry. We will prove it. Okay. Right now, I am not giving you the proof, but we will prove it. After some time, I will give you the formal proof. You can see. Look at this. We will prove it formally. We will prove that these graphs cannot be drawn without edge crossing. You can try. Okay, see what I'm telling you. You can try this graph. For example, ABC 1 2 3. Look at this graph. Okay, look at this graph. This is your complete bipartite graph. Look at this graph. This is your complete bipartite graph. This is your K33. You can try, but you can never draw it without edge crossing. So this graph, remember, we can never draw. We can never draw without edge crossing. We can never draw in 2D plane without edge crossing. Without edge crossing. So whatever drawing you make, definitely there will be edge crossing. Okay, so we can never draw this graph without edge crossing. Is this clear? Please tell me. Let me know. So remember this point. We will prove it. Don't worry. Okay, right now you take my word for granted. Okay, you just take this word. I can say you just remember this. Remember this. That this complete graph on 5 vertices, also this complete bipartite graph K33, these are not planar graph. Means you cannot draw them without edge crossing. Okay, don't worry. After some time, we will prove it formally. Okay, so very simple. So remember, some graphs are planar graphs, some graphs are not planar. So remember all the graphs, if you consider all the graphs, and we are considering all the only simple graphs you are considering. So if you consider all the graphs, remember some of them are planar and some of them are not planar. Is this clear? Some of those graphs are planar and some of those graphs are not planar. For example, we have seen this K4 is planar. Okay, and we have seen this K5 and K33. These are not planar. Okay, so remember, of course, there are more. So remember, some graphs are planar, some graphs are not planar. So very simple. Okay, now let's see the concept that is planar representation. What is this concept? The concept of planar representation, or I can say planar embedding. So what is this? See, if I give you a graph, for example, let me give you this graph K4. Let me give you this graph K4. This is your graph K4. This is complete graph on 4 vertices, right? This is your complete graph on 4 vertices. Is this planar? Is this graph planar? Please tell me. Please tell me, is this graph planar? I am asking this graph, is it planar graph or not? This graph, is this planar graph or not? Yes, this is a planar graph. Okay, yes or no? Because you can draw it without edge crossing. Remember, this graph is planar because you can draw it without edge crossing. Now, if you draw it without edge crossing, then multiple representations are possible. Yes or no? Multiple drawings are possible. See this graph, if I draw without edge crossing, then multiple drawings are possible. For example, this drawing is possible, A, B, C, D. Okay, and I can say like this. What you can do like this. Okay, so this is one drawing that is possible. This is one drawing that is possible. Okay, next, what else is possible? For example, this drawing is also possible. For example, you can consider this drawing, A, B, C, D. Okay, this drawing is also possible. Without edge crossing, this drawing is also possible. For example, this drawing is also possible without edge crossing, A, B, C, D. Okay, this drawing is also possible without edge crossing. Is this clear? Please tell me. So remember, this graph is planar because you can redraw. You can draw this graph without edge crossing. So you can see all these representations, this drawing, and this drawing. All these drawings, if you notice, all these drawings, these are without edge crossing. So this type of drawing is called planar representation. So what is a planar representation? Planar representation is a drawing without edge crossing. Okay, remember this drawing, this is planar representation of K4. This is also planar representation of K4. This is also planar representation of K4. This is not planar representation of K4. Okay, so remember, what is planar representation? What is planar representation? Planar representation, or I can say planar embedding. This is a drawing without edge crossing. This is a drawing without edge crossing. Okay, so remember this point. For this K4, okay, for this graph K4, you can notice what is a planar representation. Please tell me. Give me a planar representation. Give me a planar representation. Give me planar representation of K4. For example, you can give me this planar representation of K4. Okay, you can give me this planar representation. You can give me. If I give you this drawing, this is not a planar representation. See, if I give you this drawing, this is not a planar representation. This drawing is not a planar representation. So you can see for this K4, this graph K4, okay, this is your complete graph on 4 vertices. This is planar graph. Why? Because planar representation exists. This graph K4, this is a planar graph because you can draw this graph, you can draw without edge crossing. And remember, drawing without edge crossing, that is your planar representation. Is this clear? The definition, planar representation, or I can say planar embedding. What is the definition? Drawing without edge crossing. Drawing without edge crossing. So remember, this is a drawing without edge crossing. So this is planar representation of K4. This is not a planar representation. So remember, this is not a planar representation. Is this clear? Please tell me. Let me know. This is not a planar representation. So for this K4, if you notice, this is the planar representation. This is also planar representation. This is also planar representation. Okay. Now you tell me. So can I say what the definition of planar graph? What is the definition of planar graph? Tell me. What is the definition of planar graph? G is planar. G is planar graph if and only if G is planar graph if and only if there exists a planar representation of G. Yes or no? There exists a planar representation of G. So far, is everything clear? Please tell me. So far, is everything clear? What is a planar graph? G is a planar graph if there exists a planar representation of G. Okay, very simple point. So this is your definition of planar graph. Okay. Remember, what is a planar representation? Planar representation means this is a drawing without edge crossing. This is a drawing without edge crossing. This is a drawing without edge crossing. Okay. So this is the definition of planar representation. This is a drawing without edge crossing. Okay. Now, for example, this graph. Is this graph planar? The answer is yes. But this is not a planar representation, right? Yes or no? Is this graph planar? The answer is yes. But you can notice this drawing. Look at this drawing. This is not a planar representation, right? See this drawing. This drawing, is this planar representation? This drawing, is this planar representation? This drawing is not planar representation, right? This drawing is not planar representation. This drawing is not planar representation of G2. Okay, is this clear? So you can see in this drawing there is edge crossing. In this drawing you can notice there is edge crossing. So remember this drawing is not planar representation of G2, but planar representation exists. The same graph I can draw like this. The same graph I can draw like this. So there exists a planar representation. I can say this is planar representation of G2. I can say this is a planar representation of G2. Okay. So that is the reason this is a planar graph, because planar representation exists. Okay. So you can see this. Any graph G can be drawn in many different ways. Whatever graph G you take, you can draw it in many different ways on the 2D plane. If you have a planar graph, then there is at least one drawing without edge crossing. If G is planar graph, if you have a planar graph, then there is at least one drawing without edge crossing. Remember, there can be more than one also. There can be multiple drawing without edge crossing. If G is a planar graph, then there can be multiple drawings without edge crossing. Okay. Any drawing without edge crossing is called planar representation. Any drawing without edge crossing is called planar representation, or I can say planar embedding. So this is the definition of planar representation. Okay, you can see this is the definition of planar representation. A planar embedding of a graph is a drawing without edge crossing. Okay. If planar representation exists, then the graph is planar. A graph is planar if planar representation exists. For example, this is a planar graph. Remember, this is not a planar representation. This drawing is not a planar representation. But I can redraw this graph without edge crossing. Okay, this drawing is planar representation. But remember this point, this is a planar graph. Okay, this graph is also planar graph. This is also planar graph. This is also planar graph. This is also planar graph. Both are planar graph because you can redraw this graph without edge crossing. Okay, so very simple. But this is not a planar representation because planar representation means a drawing without edge crossing. Okay, so very simple. In the next session, we will study the remaining concepts. Okay. Satyam is asking, planar embedding and planar representation, are they same? Yes, they are same. They are same. You can call it planar embedding or you can call it planar representation. Okay, you can call it planar embedding or you can call it planar representation. Both are same. Planar representation. Okay, both are same. So you can call it planar embedding or you can call it planar representation. Both are same. Okay. The remaining concepts we will see in the next session.